Okay, in this video, we will see this problem from JEE Advanced 2019. So, in this question, they are telling that this particle which is here has mass m, and the outside one is very heavy, and the piston is also very heavy. This is capital M. This one is much larger than the small m value, mass of the particle, and there is no friction anywhere. And this heavy piston is moving inside into this with a very less speed, capital V. This V is very, very small compared to this speed which is here. So that is provided in the question. So here they're asking which of the following statements are correct. So if you're seeing this question for the first time, you can just try it out yourself. In this question, in this video, I want to use a different method other than what is available on the internet. Okay, in internet, everywhere you'll see the calculus solution. So we'll try to solve this question by comparing with this particular question with another chapter. So we'll start with the first option. The rate at which particles strike the piston is V by L. So here, one thing is clear. If it has to do collision on an average, it has to start from here. Or let's say one collision is already completed, so it will be here. It will come back, hit, and again goes here. So distance that it has to travel per collision is 2L with the piston. So time per collision is 2L by speed V. Now per collision, this is the time taken. So number of collisions per unit time will be just reciprocal of this. So V by 2L. And here it is given V by L. So this particular answer is wrong. So next we'll see the B part. After collision with the piston, the particle speed increases by 2v. So this we can easily prove by coefficient of restitution. So E is velocity of separation by approach. So initially this particle was moving with v, and this is going with capital V. So velocity of approach between them is just addition of them. So v plus v. And after collision, I'm assuming that this particle is going with v1, and question in this option, they're asking about that v1 only. So velocity of separation will be v1 minus v. So if I just do the cross multiplication, so you get v1 as v plus 2v. And what they are telling, the speed of the particle increased by 2v, which is true. Initially it was v, now it is v plus 2v. So this particular option is correct. Now for option C and D, instead of using calculus, I want to use KTG. So now some immediate questions occur in your mind. So if, as there is only one particle, why are we using KTG? It should be more number of particles. So here we are telling that in KTG, one of the postulate will be there. We'll be neglecting the interaction between the molecules. So there is no attraction or repulsion kind of things between the molecules. All are moving independently, and walls are also very heavy, which is the case here also. But instead of many particles, single particle is there. So I can easily tell, even if I replace the single particle with many particles here, answers are not going to change, because anyway the walls are heavy, and in between them there is no interaction. So velocities won't change much, or else you can tell average speeds are going to remain mostly the same. So you can just replace this with many particles which are moving with speed v, and you can apply your KTG concept here. And when you are using KTG process, we have to decide which kind of process is happening here. When you are moving piston, is it adiabatic, isothermal, or isobaric, that we have to decide. So for that, we'll understand what is fundamental difference between heat and work. So heat means we'll be supplying energy randomly. All the molecules will be getting energy randomly. They'll definitely get more energy compared to before. But as a net, let's say if you took one vessel, if you're heating something, okay, let's say you kept one burner and you're supplying heat, means everything will be moving randomly inside this. Okay, overall there is no momentum gain. But in case of work, if you observe, let's say one vessel is there. If you're pushing the piston, the molecules are gaining energy definitely, and on top of it they're gaining momentum also. This one you're sharing, you're giving energy in a more ordered way, linear or not linear, slowly will give energy to all the molecules, but here it's completely chaotic. So that's the basic difference between heat and work. So in case of heat, if you observe, gas will definitely get energy, but the net momentum is not changing much. But in case of work, when you're doing work on gas, you'll change both energy and the momentum of the gas. To be more precise with this definition, it's actually the statistical probability of the microstates will change. So, but for work, it remains same. Okay. So here the piston is moving very slowly, and we can see clearly from first one only that it is imparting momentums, okay, to the gas. Okay, this V plus 2V and all. So every gas molecule is getting some momentum because of the piston moment. So it can be treated as work, and there is nothing in this setup, in this particular setup given in the question, which supplies unordered supply of heat. Everything is properly ordered supply. So here there is no dq. So I can tell this process is adiabatic. And here this particle is allowed to move only in one direction, so it has only a single translational kinetic energy, which I'll just name it as F is equal to, so degrees of freedom will be 1. So if degrees of freedom is 1, CV value for this particular gas I can define as CV is equal to R by 2, F by 2R, and Cp will be Cv plus R, so 3R by 2, and gamma I got 3. Now as the process is adiabatic, I can claim that PV to the power gamma is constant, PV cube is also constant, and Tv power gamma minus 1 and Tv square is constant. And here V is volume, don't get confused with the V given in the question. Capital V given in the question is velocity of the piston. Now, I can tell that volume is proportional to length as area is uniform here. So, volume of this, I can simply write it as area into length. Area is constant, so I can tell that volume is proportional to L. So, wherever this V is there, I can simply replace this with L. And we also know that speed of the particle should be proportional to temperature. And I can tell from this T is proportional to V square. So both these things I want to substitute in this TV square is equal to constant. TV square equal to constant I got by substituting gamma as 3. Now T is nothing but V square. This V is speed square, and this volume is proportional to L. So this is L square. So this constant and this constant are different, but anyway they're constant. That's why I'm just writing constant. So V square L square is constant. VL is also constant only. So this one will use where V is speed, L is length of the column. Now as VL is constant, I can simply differentiate it by applying law. So you got dV by V plus dL by L is equal to 0. Just by simple rearrangement, I got dV is equal to minus V dL by L. And most of the people might think that this dV was a negative value. No, though you are seeing negative here, dL is also a negative value. So speed is actually increasing. Okay, but here 2 was given, so that will be the wrong option. This option is also no. Now last option. A particle kinetic energy increases by a factor of 4 when piston is moved inward from L0 to half L0. So here if you observe, length became half. So if this length became half, V should become 2 times only. No? So if V becomes 2 times, kinetic energy should become 4 times. So what are they telling? Kinetic energy increases by a factor of 4 is absolutely correct. Okay. Hope you enjoyed the solution.